Hello, everybody, and welcome to the show. I'm thrilled. Sorry, I haven't done a COVID update show in a while. Also, mentioned some of the vax hesitant, clickbait, popular podcasts out there spreading a lot of disinformation. And since that time, Joe Rogan has done another a big episode with Robert Malone, the inventor of all of science himself. If you'd like to know a little more about the tangled history of the mRNA vaccine, there's an article in Nature. It's called The Tangled History of the mRNA Vaccines, which Robert Malone was one of hundreds of people. And is quite openly bitter about not getting the credit he believes he deserves from some of his thoughts and work on the progress of the mRNA vaccine in 1987. And, there's a bit of a history of others having progressed other aspects of it and him not getting cut in, and he's upset about it and found a welcoming platform on the Joe Rogan Experience, which is not a science show, by the way. It's not meant to be. We're both doing the same thing we've always done. I've been randomly since for 8 years now, before COVID. I've been traveling around the world randomly. Oh, I'm here. I look up this university. Oh, sure. Okay, I booked that. Here, see what they do. I reach into a mixed bag of science and see what a researcher does. Next week, I'm having a butterfly episode, not because I think that there's an overwhelming desire for people to hear about the science of butterflies. I have nothing in my mind that's like, whoa, if I put out a butterfly episode, boy, people are going to be clamoring for that, and I'll get a bunch of clicks, and then I'll get to be famous and get a bunch of money because I did the science of butterflies. I do it because I enjoy learning about this stuff, and I started this as a hobby, and I've just continued doing what I'm doing. And Joe Rogan's continuing to do what he did long before COVID, which is to have fringe, controversial figures on his show, representing it like the other side, and gaining all of the rewards of that and eliminating any accountability by every time he's wrong. I'm just a dumb comic. What do I know? Whoopsies. And so that's just what Joe does. Sorry, I've been on the show. I know I have a lot of listeners from the Rogan Experience, and I appreciate that you're here. No, I'm not jealous of Joe Rogan. I'll take his money, but I have no interest in interviewing MMA people or celebrities, or I could do a TMZ celebrity show or something like that if I wanted to reach out and try to interview celebrity. I have zero interest in that. I do wish this show was more popular. I wish this was a more popular science podcast, but I'm super happy. Here's the top for anyone that does a better job than me at communicating science or gains any traction for doing it. I'm so thankful. I want to live in a world that's more scientifically literate. So I just Googled top 10 science podcasts that if you don't like this show, or even if you do, you might want to check out, and hopefully they do a better job than I do even. And I hope you find something even better than this at science communication. And I hope when you find that, you spread it far and wide with people, because right now what's spreading around is a bunch of gossip and misinformation that's catering to people's faulty intuitions, telling them what they want to hear. Stories of this is all made up, or this is in denial, or there's things plotting against us. That's at the root of, I know it sounds more sophisticated. They're not really saying that. That's at the root of everything being said. by people like Joe Rogan and Russell Brand and various people doing these conspiracy things. And no, diet and exercise is not doing anything different than what it was already. You were always supposed to be doing that stuff, but it's not the full picture. Bats don't get wiped out by a new fungus because they weren't in CrossFit. Trees don't get 1,000 cankers when someone brings in firewood from hundreds of miles away and introduces a new species of beetles because the trees don't that have a unsuspecting welcome host in these trees. The trees aren't susceptible to that because they have failed to do enough jujitsu or weren't doing enough supplements that, by the way, are incredibly profitable. And Joe Rogan does ads for supplements and stuff on every single episode, makes a fortune off of those alternative medicines that are quite well known for being pseudoscience. So a little, little bit of incentive there. Just eating some trail mix before I started this. Now I have a scratch in my throat. Here's the top 10 science podcasts. And just the first thing that pulled up when I Googled it. Ologies. Heard great things about that. I don't listen to other podcasts myself, but Cinema Science, Stuff to Blow Your Mind, Science Versus, Radiolab, Super Women in Science, DNA Today, The Story Collider, Hidden Brain, Science Friday. Check out all of them. I hope they're awesome. I bet they are. Science is great. So check those out. And I guess I'll just have to do like a solo episode or something, talking about Joe Rogan's experience and what his experience actually is, because I know he has smart sounding people that can peddle word salad to validate whatever he already believes, catering to, this is what there are certain things that you do. If you write a book, there are certain things that you do to say, get on Oprah or Good Morning America or Joe Rogan. There's certain demographics. There's certain ways in which you can angle that to get publicity, to get on certain things. And sometimes some stuff slips through that might not be necessarily in the best interests of science literacy so much as it is just kind of ratings driven. And this is the way of the world. So if you have questions in this episode at all, this podcast that is 100% paid for by your Patreon support, so I don't need to peddle nonsense pseudoscience, and it's totally up to you if you feel like doing that and supporting this passion of mine. But anyone that wants to go on YouTube, see how if this clickbait's working out for me. Anyone that wants to go on my tiny little YouTube channel on this humble show and ask any questions in good faith, I'll go and get random scientists, just like you can look up just your local university. I'll bet money on it. Look up your local university and just look at the infectious disease department. Pick someone randomly. Ask them if they're vaccinated. Ask them if their children are vaccinated. And because I know how every random scientist is approaching this, I know how seriously they are taking this. In fact, the guests on Joe Rogan catering to his vaccine hesitancy are themselves vaccinated. Robert Malone and Peter McCullough, who works for a professional anti-vax organization, they themselves are vaccinated. Wouldn't you find it suspicious if you found out that I was pro-vaccine but not vaccinated myself, and all of my guests were pro-vaccine but not vaccinated themselves? But see, It would take a whole coordinated effort to get every scientist in the entire world to pay off all of them. What would you have to do? Double their salary to get every single one, and then not one person, everyone's keeping a lid on it. But it takes no conspiracy whatsoever for any just wellness podcast or whatever else, or you go to your local chiropractor and they say, you don't need a vaccine. You need to come in every week and get your spine aligned by me because it communicates with your immune system. And whoa, I didn't know that about the immune system. And then they toss a bunch of word salad. Well, there's this terroir thing that was actually before the modern medicine, blah, blah, blah. And you don't know any better. It takes no conspiracy. Anyone can do that because it's not regulated. It's not subject to peer review. And then they can, one of the grifts is that you can put out a pre-published paper. So a paper that's being submitted to a journal but hasn't been accepted. So you get like a lot of these vitamin things or whatever, and they put out wellness organizations, they pay for a study and they put out something that to anyone else's eyes other than scientists, looks like any regular old study, but it's pre-published. It hasn't been accepted and it hasn't been peer reviewed. And they're like, look at this groundbreaking thing that they can literally write anything in it and get on any news platform or any podcast or thing. And they just write the one that caters to the demographic of people that they're trying to find. So keep an eye out for that. And it's often the case that you're like, well, this person, I trust them. I trust their judgment. And they mean that I wouldn't be surprised if a lot of these people genuinely believe what they are saying. It doesn't mean that they aren't wrong. They aren't working within making things falsifiable and replicatable. They're just saying like, oh, this worked for me, or I believe that. And then just like, well, just asking questions. Hey, I'm just asking questions. Joe Rogan's always like, oh, I'm just a dumb comic. Don't listen to me. Except always listen to me. Oh, but I don't want any liability, so don't listen to me. Oh, check out, this is the most important thing you'll ever hear. Listen to this, but don't listen to me. I don't want any accountability. I don't want any liability. So I'm telling you, listen to me. There are people that have experience, which counts for something. And there's a consensus amongst the most experienced people, which counts for something. Just like my guest today would not make for a very good MMA commentator, would not make for a good quarterback of the Green Bay Packers, because experience and certain aptitudes for certain things counts for something. So that's why I didn't have my guest on today to talk about various fighting techniques. I instead had this immunologist on to talk about COVID and the vaccine and the immune system. But I'll do a full episode on pseudoscience and the various clickbait that is much, much more popular than the boring old reality. So we'll do that soon, and I hope you enjoy this episode.
Are we?
Yes.
Where are we?
Here.
Why are we here? Not entirely clear. We are misfits thrust into existence by random chance, with no hints at all as to how we're supposed to make sense of it all. It's immensely bizarre. Here we are.
Hello, everybody, and welcome to the Here We Are podcast. I'm recording this at the end of the year. This is this is my first global pandemic, and I'm not sure I've made every perfect decision. And one of the things is that I was like, I'm gonna space out my COVID episodes a little bit because there's so much information out there, and maybe even presented better than I can, and I have a lot of imposter syndrome and whatnot anyway, and so I was spacing it. I didn't want to like inundate people with it, and I see people, as some people online are fatigued, and then I just surveyed my actual fans on Patreon on what they wanted more of, and they're like, why haven't you done a COVID episode in so long? I like hearing from your guests, and people like hearing kind of straight from actual researchers rather than just some of the ways that it's presented on cable news and such. So I'm so excited to have back Jessica Brinkworth, who is one of the first guests that I had on the show talking about COVID way back in the spring of 2020, and was the most accurate in in how things would go, in the fact that she was the least optimistic about the, and it's like, it's hard because like it's I never used to do social media before COVID. Now I spend a lot of time on social media. It's not the healthiest thing in the world always, but there's this argument of like, you're a doomer and you're a fearmonger and stuff like that, just for like presenting like what seems to me to be like pretty reasonable information that bears out and ends up making like a lot more accurate predictions. And so it's just such a messy situation. But anyway, that's a little spiel. It's so nice to have you back, Jessica.
I'm so excited to be here. I am more than happy to spread gloom and doom in the name of public health. I mean, that's the bottom line is that you're not doomsaying if you're giving your best assessment, right? And it's about protecting other people. So it's important to do episodes like this. Someday I'll talk about sepsis.
Someday you'll talk about sepsis, which is, well, it's related because you can get sepsis from COVID.
Yeah. So we're chatting sepsis technically. Yeah.
And that's, I mean, I think this is one of the things that's hit hardest for me was just the idea of, what was that statistic again? The number of people that die of something in like a fairly short period of time, within like 2 years of having survived hospitalized
post-sepsis syndrome. So it's pretty high. Like most people who have sepsis will die within 1 to 2 years. And they have a bunch of other problems that they come out with. They're often debilitated. They have motor issues. They have neurological problems. They have post-traumatic stress disorder. It has like real consequences. For those that make it to like 5 years, it's, they still have these symptoms. It's pretty serious.
It's amazing. And this is like on this person's like obituary or whatever. It's not citing sepsis as the cause. Probably, it's probably like they suffered a heart attack or some other issue that was related to it.
Yeah, absolutely. Well, and so that's even true when it's acutely sepsis that kills people. It's true when it's acutely COVID that kills people too. There's a lot of I think that's one of the things that's really unfortunate about this pandemic is that there's this fairly homogenous cause of death of infectious disease death in the US right now. And a lot of it's being underreported because coroners are writing proximate causes like lung failure. They had a heart attack. But if SARS-CoV-2 is mediating that heart attack, then, causes SARS-CoV-2, right? But there's, and at the end of the day, what it means is that a lot of problems are not actually being addressed. So.
Yeah, I mean, one thing, I don't know how much you know about this subject, and I don't know how much there is to know about this subject. I haven't kept up as much as I probably should, but I had one of my highlights of 2020 was I reached out to my science hero Robert Sapolsky, and I got to sit in on a class. I was like, all these people are teaching virtual classes. I would love to reach out to a few of my favorite past guests and hear them like actually give a class. And he talked about aging related brain diseases,
right,
and also brain diseases generally. I think there was a class on schizophrenia as well, which isn't age related, but that was the gist of most of it. It was very high level. He warned me about that beforehand. I did not have the prerequisite knowledge to be there. I didn't understand half of what was going on. I was very inspired to hear a bunch of young people that sounded like absolute geniuses to me, trying to hash out these various complicated issues. And so a couple of the last classes before last December were on Alzheimer's and Parkinson's. And Sapolsky, who's definitely no fearmonger, he writes books about like mitigating chronic stress and stuff. And he mentioned that COVID seems to be working in some of the same ways potentially as both Alzheimer's and Parkinson's, and as what he was explaining was beyond my comprehension level, but I've since seen lots and lots of issues, neurologic issues coming up from COVID long haulers, and even people that had a relatively easy go of COVID in terms of the acuteness of it, but then having long-term issues afterwards.
Right. Yeah. So it's been known for at least a decade that coronaviruses can jump the olfactory bulb, right? So the olfactory bulb, at the very top of the nose, part of the brain that extends into the nose, right? The olfactory bulb has always been sort of posited to have very particular and special and not terribly well defined immune mechanisms to prevent this from happening, because you do take in an awful lot of stuff through the nose, right? And so we have like upper respiratory infections all the time. And yet not necessarily long lasting brain damage, but it's known that they can, and there's other viruses that can do it too. And so that's been known for a while. What we knew before SARS-CoV-2 is that what happens when they jump is that they can trigger apoptosis. So they can go in and sort of trigger programmed cell death in neurons that are there. And this has been posited to be one of the reasons why people have like a loss of smell and taste, because it's jumping this bulb or it's in the bulb, and it's able to like kill cells and replicate in those cells and kill cells in that region. And so that leads to this loss of smell and taste. But we know that it can be in the central nervous system generally. And so that's been known for like a long time. I think what we have right now is so many people sick with the same thing that we have like a really, really large cohort of people that have post-viral syndrome or some variation on it, which can involve neurological issues. And so, so what's happening, what's different right now is that we have something that's highly transmissible, and it's disseminated globally so well, and there are lots of people that are recovering and have this syndrome. So it could. So one of the things that happens in Alzheimer's is that I'm not sure how selective it is, but there's definitely misfolding of proteins, this concept of tau tangles. So like tau proteins sort of getting all sort of tangled up is really important. It's this sort of disorganized protein production and folding that then leads to certain cells in the tissue dying. And so in the absence of those cells, you have neuropathways are broken up, right? And so I'm not saying that it's the same. I'm saying that very, very similar thing is happening when
not
some
necessarily
of
the
same cells
seem to be right.
Not the same mechanism, but yeah.
Right. That's do you have any sense of how often people are experiencing neurologic issues? Because it seems like lots of people are losing their taste of their sense of taste and smell and writing it off as like, oh, don't have my
common.
smell, but is that potentially like?
So I don't have an exact number. I can tell you, I don't know that anybody has an exact number. I don't have a number. I can tell you that the loss of sense of taste and smell is significant enough that it's listed as a common symptom of the infection. So it's pretty common. But in terms of the numbers of people that are long hauling, so there's some confusion, I think, over a definition of what a long hauler actually is versus who's suffering long COVID symptoms, which would be different from saying persistently having the virus in the system. So, so you could split these groups into people who are consistently providing positive tests. There's obviously persistent viral replication going on way past what would be the normal, course of like a month.
This is news to me.
Yeah, so
actually,
that is something that happens. There are people for whom this is happening. But I think that those people are probably in the minority. The vast majority of the things that I've read on long COVID, it's fairly heterogeneous, but it all looks like variations on post-viral syndrome, which is so poorly defined that you could shove an awful lot of stuff. It's like a trash can kind of definition. You could shove an awful lot of stuff into there. But yeah, so the fatigue and mental fogginess, protracted coughing, other neurological issues, it's pretty significant. Apparently it can last a really long time. There are people that are recording having these symptoms like 2 years out from their initial infection. So
I mean, it seems like something like brain fog is. I've blasted so many drugs into this brain of mine in the course of my lifetime, and oh my gosh, the amount of alcohol I've dumped in here is ridiculous. But so. The fact that I've done, and then I'm like so concerned about COVID, which I am, but it just seems like something that would give you brain fog for a long amount of time. The potential long-term consequences of that seem really pretty serious.
And they can be. Yeah, they really, really can be, especially if you just think about the basic stuff that you have to get done every day. And there's variation, right? So there's, people that have brain fog, when you have the flu, and, people that are really struggling to remember to do basic tasks and things like that. So it's pretty bad. I will say, it's also a symptom of menopause. And it's also a symptom of a lot of other conditions where it's been broadly dismissed. And frankly, post-viral syndrome overall, it's something, in my personal experience, it's something that gets sort of hand waved. It's we can't really treat it. It's this post-viral syndrome. Don't worry about it. The difference is that this infection is so significant. And then on top of that, there are so many people with it. It is really important. So what I would say is that one thing you want to make sure you do if you have COVID is that you get a record of a PCR-based test in the course of doing it, if you can. I think that's going to be important for all kinds of things, potentially making disability claims or any number of things that might be associated with it. I wish that wasn't the case. But I think that might be the way that things go, especially because there's, governments do things that are not ideal.
So this is, we're recording this on December 29th. And a few days ago, the CDC made a pretty controversial decision that seems like I remember the last time that you were on, you were kind of complaining about the CDC's like in my view rather naive mask advice, which is like, if you're vaccinated,
it's totally fine, you guys.
It's totally, which is like, well, people that aren't vaccinated aren't going to just like, all right, I guess I'll be honest and keep my mask on.
Never mind.
Like,
that all of those drugs were either, they were authorized at the time, right? Not indicated, but they were authorized for severe infection, prevention of severe infection. Ergo, like necessarily, like the data for those vaccines showed that people could get it and be symptomatic, but they just weren't ending up in the hospital. So it to me seemed very cold and calculated and not an appropriate guidance when nobody under the age, when it was originally released, I'm not even sure anybody under the age of 18 was vaccinated. Certainly nobody under the age of 12. So that's like 50 million kids that were not vaccinated. And it was like, it's fine. Well, it'll be totally cool. Don't worry about it.
Because I think that there is like a reasonable case to be made in a perfect world. You know, it's like behavioral economics where it's like economists realize like, oh, people they aren't computers that make these perfect calculations and whatnot. And if that were the case, and maybe it still is in our imperfect human experiences, that you know there's kind of some amount of control fatigue and there's and when there's a projection where there's going to be a dip and it's summertime and people can be outside and grill and everything else, that you kind of like, hey, we're going to loosen this up for a little while, and when a wave comes, we're going to, you know, increase the, you know, threat level again and maybe put some public mitigation back in. But to me, it seems like the toothpaste is out of the tube and there's like no way you're getting people to go back.
It was an extremely poorly thought out guidance that some other nations adopted and other nations just scoffed at. And there's good reasons to scoff at it. For one, it was released at the end of May, beginning of June, at a time that the bulk of the United States is in temperate biomes. Some of it's not, Texas gets, pretty hot. Arizona obviously gets super hot. There's desert regions where it would be important to be indoors, for the protection of in order not to be heat fatigued and, or worse. Right. But it was released at a time when a lot of the nation, certainly the most populous areas in the nation, could have these outdoor get-togethers. So why specify that it's okay to be indoors and vaccinated without masks? And then they put on, it came hand in hand with a bunch of other relaxing of standards that I felt were not appropriate at the time. And as all compensation, I think, for one thing that they did at the very beginning, which was too harsh. So at the very, very beginning, there was a bunch of guidances that came out from a variety of jurisdictions that said, if you test positive, if you have symptoms, because nobody could get a test at the time, it's 14 days in lockdown. That's it. No matter what you have. And then when it could be tested, it was 14 days in lockdown, which was probably unnecessarily harsh, right? If you were a contact, it was 14 days in lockdown. That was unnecessarily harsh. So the idea was that the bulk of people will probably express symptoms by day 14. There was evidence in China that by day 14, there were people who were only expressing symptoms at day 14 at that time. And so that was the rationale for it. And then it was held on to for a really, really long time when it became obvious that most people will become symptomatic in the first week. So they rolled that back, which I thought was a great idea, because it was so punishing to people who were, say, hourly workers. But at the end of the day, all of this, these are economically guided decisions, and that needs to be part of it. But, so much of the American workforce is hourly and precarious and doesn't have the ability to stay home 10 days, not because they don't want to, because they can't they can't pay their bills like that, or their employers won't allow them to do it. And so to bow to employers rather than doing what other nations have done, which is say, like, you can't, and you have to pay them when they go home. You can't tell them they have to come back after 7 days or 5 days or whatever. Like, so this thing that the CDC just released yesterday or the day before, I can't remember. I've been angry about it for, it feels like 48 hours. So that seems, we'll use that. I think it came out on the 27th. So that guidance says that if you're positive, if you get a positive test, regardless of your vaccination status, if you get a positive test, you only have to isolate for 5 days if you wear a mask for the next 5 days. So that effectively what they're saying is that masking is so efficient at, blocking transmission that if you can leave the house if you're wearing a mask, it's going to be fine for everybody else. 10 days of isolation technically, but 5 of them are on your own and the other 5 are just masking. And it's stupid because on the one hand, it relies on people doing something we already know they aren't doing. So we already know that a lot of people aren't masking. There's lots of evidence that that's the case. One of the most stunning...
You can go outside and use your eyes even.
You just use your eyeballs. But one of the most stunning things for me is that if you look at the CDC's count of flu cases for this last year, you can see the bump at Halloween, a bump right after Thanksgiving, and they're climbing like typical arc for an almost typical year. And that's happening because the flu has an R naught, a transmissibility. One person's going to transmit it to 1.5 people on average.
Oh, and COVID, the first variants of COVID were 2 for comparison,
2.5,
correct? And then,
right.
and now they're much higher
this
with the new one, which we'll get into.
Yeah, this one could be as high as 10.
That's almost measles.
Yeah, it's pretty serious. So we already know, if you watch the flu data, you can tell, it just as a proxy, you can see that if people were doing the things that they're supposed to be doing for COVID, flu wouldn't be going up like this. Flu is going up like this because people either can't or aren't, right? They either can't do it or they are choosing not to do these protections over this period. And it's going up with the holiday season as it does, right? So, flu is seasonal anyway, but seasonal flu cases are up. So that, to me, is for the CDC to have this data and then to say, okay, but you guys, it's totally fine. You guys can mask and roam around, that's fine. But it pleases big business. So one of the things that I think is interesting is that Bloomberg today was reporting that this 5-day measure lines up almost exactly with the ask that Delta Airlines made of the CDC when they were consulting stakeholders. They requested a 5-day limit. And so somebody better skilled. Yeah, you saw that, right? Yeah. So that was Bloomberg. And then there was a couple of other outlets with CNN, I think, reported it as well. So someone who's more skilled in journalistic integrity and how, and how things are reported could tell you more about that. But that to me was really disheartening.
To me, it feels like the both the mask thing and this, it felt like a little bit of a betrayal, and it just made things very difficult because before that I felt like I could go, well, just follow some simple CDC guidelines. It's the Center for Disease Control. Right. Just listen to what they have to say. That's the job. We're all working in this system, and then it's just I don't know. It just kind of I thought it really ruined a lot of the credibility that they which for some people was already there was already a lot of people that were never going to listen to the CDC. Yeah, when the Trump
administration started burying data that was coming in on COVID under higher ranks of Health and Human Services, I was already sort of feeling okay, well, if I want this information, I'm going to have to go somewhere else than the CDC. Yeah, but then I felt a little bit like I can pick or choose, and this period of time is ending, right? It seemed pretty obvious that was going to stop. But the guidance in May was clearly around reopening the economy, which is whatever is legit, but it was not a good guidance. And then, and this is just like in the middle of this wave, like we had how many cases I think today we have something like, I actually wrote the number down on my screen so I could remember. The 28-day average right now in the US is 4.6 million cases that are live like right now. That's
amazing.
Bonkers. That's for a total of 53 million, right? So now we're at numbers like last year.
Yeah.
So this is like, it's upsetting because this is a virus that maims, right? Even when you're vaccinated, it can maim. So this isn't, you know, we've talked about this before, but death is like a super high bar. Right? So,
survival is like such a when people talk about the survival rates and first off, all of that is like any one of these people that are like, you hear really not to pick on the couple like negativity bias screwballs that hound me on social media, but you see a regular like meme thing go around that's like, you have a 99.97% of survival. And I tried to explain to this person, I was like, so what you're saying is that for every person that died from COVID, 10,000 people got COVID and didn't die, for every 3 people or whatever the math was. And then I was like, I worked it out. I was like, so if 800,000 people died, that means that, by your numbers, that means that 4 times the population of the United States has had COVID and survived it. Right. Can you like? But people aren't great at statistical reasoning. Not that I'm the best at it, but I always had a fondness for math. But if you were to ask any of these people, like, here's a bag, reach in this, it has 100 balls in it, reach in this, and one of the balls kills you. Just reach in the bag. Like, I don't think people would want to reach in that bag.
No, most people would probably say no. What's the benefit? You could go to McDonald's and eat with your mask off if you just reach in the bag, like, or you can do like, it's the things, right? The things that we perceive as being like so necessary. There is a fantastic Twitter thread that I'll quote and put you on so that other people can see it, on like things that we've discovered about, I don't know if you saw it, but things that we've discovered about COVID, which, for example, if you're lined up, you need to be 6 feet apart from one another. Did you see that?
I saw you retweet it. Yeah. That was a fun.
But it can't move perpendicularly.
Was a fun use of satire. Right.
Everything is fine. It being in an enclosed space that was built before 2020 is like not good. But being in like an enclosed space that was built outside, like those little like restaurant tents between August 2020 and now, totally fine. Yeah. Yeah.
I mean, there's a lot of, I'm a big fan of cognitive biases and which doesn't stop me from experiencing them, of course, but there's a lot of, motivated reasoning, of course. And it's weird. These little, people really have a fondness for nitpicking, like things that don't make logical sense. So within that thread, it's like, it's you can't get COVID if you wear a mask to the table and then you take it off when you're dining at the restaurant or whatever. Well, people see that and they're like, oh, it doesn't make any sense. And like, yeah, you're right. It doesn't make sense. To me, that means don't do indoor dining because what's happening in there does not make sense. But a lot of people see that and like, oh, it doesn't make sense. Therefore, let's just forget about anything and not do anything at all. Did you watch?
So good.
Did you see Don't Look Up yet?
Okay, no, because I just haven't gotten to it. I decided that this was. So this is a little bit of a story, but I saw Westworld when I was a kid. Terrified me. And then I tried to watch it again in my 20s, and I still, like, you'll Brenner freaks me out, so I just can't like watch it. So finally, I was convinced to watch the first season of Westworld, and I prioritized that over Don't Look Up because I was like, "This is the moment, man. Yul Brynner's not even in this one." So,
did you enjoy it? It's a very good show.
I just got to the last episode of the first season last night, and it's pretty badass.
People didn't like season 2. They thought it was too complicated. I thought it was just upping the stakes.
Yeah.
I thought it was brilliant. And then I thought season 3, they kind of pandered to the crowd a little bit and dumbed things down.
Yeah, first season is pretty stinking complicated.
It gets more complicated.
Oh my goodness. Okay.
And I think a very good way. I mean, when they use words like heuristics and stuff like that in ways that usually when you hear them on a show, it's like they're just throwing word salad to make something sound smart, whereas Westworld actually thought through.
The code looks familiar too. The way that it's written, there's a couple of coding devices that I use that like literally look like that code. Like it looks an awful lot like the way that Python is scripted. There's a couple of different languages that look very similar to the way that they did it there. And the other thing that's sort of interesting about it is Anthony Hopkins lets out a line in the middle of it where he says something like that. It was a way of bootstrapping reality. And I was like, hold up. And I had to sit back and think about like the statistical process of bootstrapping to like see if it's fun. It's a fun show. Yeah. Anyway, so no, I have not seen Don't Look Up.
You're going to get some very cathartic laughs. It's like it's made for scientists.
Oh, that's awesome.
Sure.
I'm sure I will. Okay, so I'm very jazzed about seeing it. But so So
we were back at people. We'll get back on track. We were back at people. Kind of like a common response is you see something that doesn't make sense, like a restaurant's policy or something like that. And because of that, you go, none of this stuff works. And it's kind of, there's a certain like incredulousness to it. And there's like some like bystander effect stuff going on too.
Yeah, for sure.
People are just like, someone will figure it out. They'll figure it out. Meanwhile, it's like the same people. This happens with climate change where it's like, they'll figure it out. And I'm like, but they're telling you.
You're responsible. Like you got to take, you got to do something. Yeah. I mean, So one of the things I think is kind of interesting is that I feel like there is a lot of going along with the crowd. A lot of people use the CDC May guidance or June guidance to say like, I can do this. When we had information that suggested that, no, you really shouldn't be indoors without a mask, whether you're vaccinated or not. But it gives people there's an authority. This authority said I can do it. That's fine. The other thing that I found is that I get a lot of personal pushback. You're saying I can't? No, I'm not saying. The virus works like this. Yeah. I'm just telling you how the virus works. If you want to do this, and think highly individualistically, I guess that's your jam. One thing I will say is that there's a couple of interesting things about Omicron in particular. So let's get the notion of mild infection out of the way.
Yeah, that seemed like such a bizarre, like, why even assume that? And it's just like, it just seemed like the same wish thinking that I've been watching people exhibit for nearly 2 years now.
I think it's worth noting that when the first papers came out of China describing this, the first 3, so it's Zhu, Wu, and Chen, I believe, are the first 3 that come out. And I think they're all in the Lancet. And one of them's in a Chinese journal specifically. I can't remember the name of it. But anyway, in one of those, and I think it's Chen, they go through the process of describing, we can break this down into like 3 or 4 categories. And the first one is asymptomatic or paucisymptomatic, meaning so like the symptoms are disorganized. People don't recognize them. Or asymptomatic entirely. Then there's mild. Then there's moderate. And moderate is pneumonia. And then there's severe pneumonia. So severe pneumonia is on a ventilator. Moderate, you require supplemental oxygen. Anything below that is mild or asymptomatic. You can be pretty damn sick and have lasting consequences with even the flu and not be on supplemental oxygen. And so that's the thing that is really upsetting, is that when they say things like Omicron's going to be mild, this, or any time that this thing has been described as mild, it's really not accurate. Because for people who are going to be symptomatic, that range can be quite far. And in mild and asymptomatic cases, there have been plenty of people that have come up with myocarditis. So that's like heart inflammation, which can be quite damaging, pulmonary fibrosis. There's, there are real, and then of course, post-viral syndrome. So the bulk of cases of long COVID, of this like big, post-viral syndrome, they're mild. They started off as mild cases. They just are mild cases, and it gets cleared, and then people are left with these problems. So it's really not fair to describe it that way. One of the things I think is really interesting about, sorry, go ahead.
Oh, I was going to say that additionally, it's kind of graded on a curve in a way where that's primed and influenced by how overwhelmed the hospital is too. It's that assignment of what's mild. It's like, well, what's your that's a kind of a byproduct of hospital triage, right? Where it's like when shit really hits the fan and you need to prioritize the more severe individuals, then mild becomes a different thing. Right.
And so if you have cardiovascular disease and you're manifesting COVID somewhere between moderate and mild, you don't need supplemental oxygen necessarily, but you're maybe a little bit worse than you ordinarily would be. You're still at risk for a heart attack. You're at an increased risk for a heart attack. And there are plenty of people in New York City that died because they couldn't get care. Who died not just of COVID, and certainly not just of severe COVID, but died of other conditions, right? And so, it has this massive impact on everyone around us. So why not be responsible? Like, why not, why not mask? Why not choose to not eat inside a restaurant? Like, why not choose to eat outside or take your food outside? Like, I haven't been in a restaurant since the very, very first week of March in 2020. And that was a very uncomfortable experience anyway. It deliberately went like on a Tuesday. I was like, this is going to be the last time. So let's just do it. And so maybe part of it for me is that I personally don't understand a drive to do it when the risks are high, and not just for me, but like for anybody else. I don't know who I'm going to take this to. And I think that most people, if they had to actually look at what their actions have done, for those who have transmitted it unknowingly, if they could see the chain reaction and how that like who dies and who suffers, all that loss, what we have, like over 820,000 people have died in the US of this in 2 years. Like, that so well outstrips any other infectious disease in the US. In recent memory anyway. Like, I think if most people could see that, right, could see someone on a ventilator and know that it was due to their transmission network, they wouldn't do this, right? Most people confronted with that would probably say, okay, I don't need to hold a party for my birthday. Or, like, most people would take precautions.
Yeah, I mean, I've been in a tricky situation because 95% of my income was from live performing before COVID, and I'm the last comedian that isn't touring. The last. Really? I mean, there's people. Oh yeah, I can't think of a single other comedian that hasn't toured like this year, and there's I did one weekend emceeing event that I booked back in May. It was in October, early November, and it was all people needed proof of vaccination and or a negative test. Funny thing, it was emceeing a psychedelic conference, which has a mixed bag of people. Sure. And so I booked it like months in advance when things were like, I was feeling a little more optimistic, like in May or whatever. And anyhow, because of it, I saw so I was emceeing and bringing up each presenter, and I could see they all had to either have their vaccine proof or and every scientist at the conference was vaccinated, and every like wellness guru person was unvaccinated and taking the test, of course. And it was just like very, very predictable. There's a lot of wellness grifting going on in all of this of presenting kind of like, oh, don't listen to mainstream the medical community. Come and get my product that I got some shady kind of certification to give, and like a supplement that you like got to pay for and take every day that, you know, hasn't been in a double blind study or isn't regulated or anything else. And that's going to, you can just take vitamin D or whatever, which vitamin D is fine to take, but it's not protecting you from COVID. It's not going to do
shit. Yeah.
And it's a missed opportunity because they could instead be presenting like, in addition to getting a vaccine and you know, doing these other ways to mitigate from getting COVID to you know, keep protecting your health, you should also, you know, work on your nutrition and exercise more. Terrific. Instead, they're presenting it as an alternative.
This is the alternative. Yeah, that's not cool. To be clear, I'm not saying that everyone has to, like, my living circumstances haven't changed all that much. I did get to see my parents for the first time in 2 years. We timed that very specifically, involved testing. It was a risk. I had to buy a porta potty for my car. So this is,
excuse me. Let's get into that.
Yeah, this is really fun. So I'm from Canada. My parents are in Canada. So Canada has some pretty stringent rules about who can be here and what they can do. So you have to pre-register with the government that you're coming across. You have to get tested within 72 hours before you cross. Then you have to be tested. You have to be vaccinated. And if you can't be vaccinated or you have a child under a particular age, then you have to all be vaccinated or not vaccinated. You have to test on day 1 and day 8. And you can't be around people that are over the age of 65. There's all these limitations. You're not allowed to be like involved in like the social world at all. So we followed all of these things. And one of the problems for us is that we have to cross at Detroit, but my parents live about 10 hours past that. So where are you going to go to the washroom? At least where are my kids going to go to the washroom? So we get questioned at the border. And so we bought, even though we were traveling, we like timed it so that we were traveling like middle of the week when no one else would be around, very early in December when no one else would be traveling. And so we bought this little collapsible potty. I wish I didn't bring it here to show you, but it's actually kind of awesome. It folds up like an accordion. It has like a little like toilet seat on the top. It's like a trash can with a toilet seat. So that was one of the things that we bought on the off chance that we'd have to like go to the washroom on the side of the road with the kids. So yeah.
Wow.
Yeah. Well, so in my case, I have 2 kids, one of which is now vaccinated, but the other one's not. And one of them's at risk. So that dems the brakes, right? It means pooping on the side of the road. That's what she's going to have to do. So that was the way that we approached it. But all of that said, it doesn't change the fact that we still could have carried it with us. We did everything that we could to make sure that we didn't, but it's always possible. So I'm not suggesting that people be completely shut down. I just think that holding a Halloween party is not appropriate.
Yeah.
And there's things now around Omicron that we know that we didn't know about a month ago that I think are kind of important that we should maybe talk about if you're into it.
I'm very into it. Actually, you know what? You know what we never did is I didn't have you share your background and actually it was like, oh, we just I'm just like, some people might be like, oh, who is this lady? I forget. This is the curse of knowledge bias right there, where I just presume people have information that's in my head.
So I'm an assistant professor of anthropology. I'm an evolutionary immunologist. I'm at the University of Illinois Urbana-Champaign. And I study the evolution of the human immune system, and I specifically focus on severe infections and, asking the question, why do some people get sick and other people don't? So, yeah.
Go back through past episodes as well. She's been a great guest. This is the 4th time now, I think.
It's like my 3rd time to screen. Because we have a whole 2-hour conversation that didn't... A 1-hour conversation that we lost.
That we never published, yeah. All right. So, first, before we talk about the new variant, can we? You mentioned myocarditis. That's something that's being peddled as a large vaccine risk right now, and there's like some of the conspiracy videos that go around are like it's like a soccer player in Ireland that fainted on the field, and you find out later it's like they actually had COVID in the past and weren't vaccinated, but they're just like showing footage of this person that was dehydrated and fainted, like sometimes happens on a soccer field. But it's a big thing being like Joe Rogan and stuff. People like that are like retweeting stuff like that. And as I warned you early on, that guy was going to be a problem through all of this.
Oh my goodness!
And he's a huge problem.
All from news radio to this. It's just sort of stunning.
Yeah. It's the thing is he likes fringe it's like he doesn't just have an archaeologist on his show. He has someone like digging for ancient aliens or whatever. If you're going to be an archaeologist and you want to get on a show, you better be like looking for aliens, Bigfoot or some shit. And so to get on his popular show that can make some people rich, you kind of need to present some sort of fringe thing. So I think there's even like otherwise fairly legitimate scientists that either go unnoticed or present or bias these kind of fringe narratives to get on there, right? Because it's the only way. He doesn't present science scientifically. He doesn't randomly sample a university. He finds people that are presenting this alternative point of view or whatever to get on, and it's the most popular podcast in the world. So it has really? Pretty big impact. Yeah. No. Yeah, he has like 14 million listeners or something.
Jesus. Okay, so this is unfortunate. I definitely saw him in a television show in the 90s where he held a contest where where people had to eat bull testicles.
Fear Factor. Yeah.
Is that it?
Yeah, it was called Fear Factor. Yeah. Yeah, and then he had a show where he like looked for Bigfoot and stuff. And nice. And his most requested guest is Alex Jones, if that gives you an idea of the.
Nope, that is more than enough information for me.
Yeah.
So what I'll say is that myocarditis, in most cases, the cause is not known, but common causes are infectious. When it is identified, the common causes are infectious, and it is like not uncommon. There's a couple of really important diseases where it can cause really debilitating myocarditis. In most cases, it's a virus that causes it. So SARS-CoV-2 is definitely one. Hep B is definitely another. Parvovirus is another one. Parvoviruses are cool. We should talk about them another time, but they're really interesting.
What are they?
Ancient positive stranded RNA viruses. They're at least 4.2 billion years old. And they do some pretty cool things. That was some of the first forms of life. Yeah, right? Yeah, so they're pretty, at least they have their roots about not parvoviruses specifically, but positive stranded RNA viruses are at least 4.2 billion years old. And then parvoviruses are some of the older positive stranded RNA viruses. But again, like the way viral evolution works, it's so fast, like parvoviruses specifically emerged more recently than that. But anyway, they are cool. We should talk about them another time. Certainly HIV can cause it, and so can Epstein-Barr So there's like a bunch of very common, Epstein-Barr is super, super common, right? Mononucleosis, super common. These are all known side effects of that. And then there's a bunch of viral agents we don't know anything about. Plenty of bacterial infections that we see in lots of the population with things that constitutively live on you, like streptococcus, can cause myocarditis as well. So there's lots and lots of ways that this is happening. And of course, like you can even get it from yeast. Chagas disease, which is Trypanosoma cruzi, is another cause. Darwin probably had myocarditis stemming from Chagas disease based on descriptions that he wrote about himself. So like, it's very, very common. But basically, not very, very common, but it's more likely to happen from any one of these things as opposed to a vaccination. And I know that there's rumors going around that it's the most common cause of myocarditis, that mRNA vaccines are the most common cause of myocarditis in children, but it's exceedingly rare. It's an exceedingly rare side effect for something that plenty of things that are already living on those kids could cause. So
yeah, I looked at the rates. I don't remember them, but I looked at the rates of myocarditis according to the CDC, and even if they were off or lying or something like that, it would still be. It was like it would need to be 1,000 times. They would need to be off by like 1,000 times or something like that to get anywhere near what the actual virus is doing to people.
Yeah, absolutely. And so, we know that SARS-CoV-2 causes it even in asymptomatic people. Why would you risk it? Why, that's like a guaranteed versus something that can happen to a very small number of kids that were in a trial for which we don't have, like, it's very, like it could be from any, I actually don't know if they were in a trial. One of them was in a trial. I can't remember about the rest of the early cases, but at a time when we have a virus circulating that we know causes it. And so one of the things that can happen in these reports, and it can also happen in trial data, is that because of the time it takes to identify, you can have a virus, but before you have a load that can be found, like a viral load that can be like identified, you can manifest symptoms. So there's a bunch of things around this that I think are not.
I went to a Christmas gathering with my relative. It was like, it was going to break my mom's heart if we didn't go to this thing. The issue is that most of my extended family is anti-vaxxers. And I mean, most of them have had COVID already, and they don't share things when I'm around because I'm the science guy, but I couldn't step around a corner without hearing some long COVID symptom like story that they were, and it'd be things like I have a cousin that's like 35, in good shape, does CrossFit and stuff, and she got COVID months ago and was like, yeah, the COVID wasn't too bad. It's just I just don't like all the heart flutters that I've had ever since. And I was like, oh, that's like you should go to a doctor. Like, you want to have that checked out, right? Like,
yeah.
If you're having heart flutters, like, because it's my understanding that there's treatment for myocarditis, right? Like, it's not something that you just want to ignore.
Yeah, you certainly don't want to ignore it. Figuring out what the extent of damage can be really, really important as well. I'm not a clinician, so it's not really fair for me to say. Yeah. You absolutely don't want to ignore it. One of the problems, a lot of people we think maybe have acquired it because they were participating in heavy activity before they knew they were infected or before they were like knocked down, So
I see.
Yeah, so there's like, you certainly don't. Because it can have like long-term, depending on your age, it can have like significant long-term ramifications.
So that's interesting. So if someone is particularly athletic and taking part in a lot of sports and they get COVID, and before they're symptomatic, they're exerting themselves, they're potentially more damage is being done before they're aware of symptoms.
Yeah, that's something that can be happening. And so myocarditis in the act right before it stops, or, you know, and you end up with like fibrosis and issues around that, can cause heart failure. It can certainly cause a heart attack. And so like when it's in progress, you absolutely need to see somebody. You know, knowing that you've had it, your cousin has disturbing symptoms, she should probably see somebody, right? Yeah. So that is one thing that happens. I mean, in the worst possible cases, so it can absolutely cause arrhythmias. In the worst possible cases, right, you can have like, well, what do they call it? Sudden cardiac death. Is that the term? Yeah, when your heart just stops. So yeah, you want to check it out. So
Omicron.
Yes, let's talk about that. Okay. Right. So, stepping back for a second. If you want to avoid it, since there are so many known viral causes for it, you want to make sure that you're not around. You want to protect yourself from getting respiratory viruses, basically, or, you know. Yeah. Okay. So, Omicron. All right. So there's a whole bunch of interesting things about it. For one, we don't really know if it causes mild infections only or predominantly. It's so transmissible. And this transmissibility may stem from 50 amino acid mutations in this variant. So compared to the original variant that circulated the globe, or the original two variants that circulated the globe, because we can talk about that, but there's two lineages of COVID, one of which is like not very successful and the other one is global. So that's the first thing. There's 50 mutations overall. Some of them are really significant. I was looking at them a couple of weeks ago. A number of them land in what's known as the receptor binding domain of the spike protein. So for COVID to get into a cell, for SARS-CoV-2 to get into a cell, this spike protein has to bind to a cell receptor, and then the viral envelope has to fuse to the cell, and then the RNA gets shot in, and then replication happens, and we make lots of little viruses and blah, blah, blah. But that binding of spike to the receptor, and this specific region that does it, the receptor binding region, that's pretty important. Then there's regions around it that change in shape with that binding. So those are pretty important too. And there's a slew, about 36 of these 50 mutations are happening just in spike, and a bunch of really important ones that seem to change the shape are happening in that region. So we think that maybe that might contribute to it being more transmissible, but it definitely does appear to be more transmissible. The last estimate I heard for R0, like infectivity, is something like 10. So to put that in perspective,
that's like one of the most transmissible things that we've ever seen.
Yeah, right? That's pretty. It could be as high as 10.
Isn't measles number one? And
yeah,
that's like 15.
Yeah. Huh. Pretty high. Yeah, pretty high. So to put it in the frame of SARS-CoV-2 and influenza. So influenza is something like 1.6 or 1.7. With the original version of SARS-CoV-2, like with alpha, it's something like 2.5. So it was already exponential out of the gate. Delta is somewhere just below 7, somewhere between 6.5 and 7 people for every person infected. And we thought that was pretty terrible. This could be as high as 10. I don't have the exact numbers. It's pretty bad. So then there's a bunch of stuff about it that's really interesting just on its face. The first is that people with prior infections, the WHO is reporting anyway, the people with prior infections seem to be at an increased risk for reinfection with this specifically. So no idea why that's the case. Honestly, most humans don't develop a super robust memory response to COVIs anyway. That's something that's really new. But wild type coronaviruses, they leave like a small scent behind them. Basically, like there's not really robust memory, and then after that memory dies off pretty fast. So that's the reason why getting vaccinated is so important, because we get this like much more robust immune memory in response to the vaccination than we do to the whole virus, which is like so good at escaping everything. So there's this weird thing where this seems to maybe be the case. We know that the PCR tests that are being run that are trying to amplify sections of spike specifically, that's how the detection works for those tests, that they're effective. But the FDA yesterday announced that it thinks that maybe all of the authorized rapid antigen tests aren't. They're not as effective, that they seem to have issues. These are tests that, the at-home tests that give you like 2 lines or whatever when you spit on them or swab them. There's 42 of them on the American market right now. So I haven't had a chance to go through all of them because I've had other things to do. But I looked at 2 that were pretty popular. One, Binax, which is commonly used and seen everywhere. And then another one by Celltrion. Both of them use antigen, at least antigen from the inside of the virus, the nucleocapsid. So they identify some part of that. And then Celltrion also, I believe, uses part of the spike protein for identification. When these things were authorized, they were authorized with the idea that a negative is not a confirmation of negativity. It's just not a positive. And so, but on top of that, there seems to be some issue around sensitivity. Some of this stems from when the FDA and, I shouldn't say the FDA, when the companies were originally running tests and the FDA did cross checks on these things, they were using heat inactivated virus, between November and say like second week of December, when they ran tests using these things, they were using heat inactivated virus. When they used live virus from live cultures from patients, all of a sudden the detection dropped. So there's potentially a couple of reasons for that. If you heat inactivate a virus and you break the virus down, a lot more of the nucleocapsid hypothetically is available to be seen, like by these tests. And so that's one possible reason. Another, even though virus lives and dies and this stuff is getting shed all the time, but there could be other reasons too. Either way, they send out a warning, don't take a negative to mean like an actual negative. And these are tests that, to be clear, already have a pretty wide margin of error. So that's one of the things that might be happening is that we had a whole bunch of people that did what they were told they should do, right? They got together for Thanksgiving, vaccinated, did these tests in advance, showed up, and then were positive afterwards because the tests themselves were not detecting it like accurately. So, I mean, there's a lot of people I think that are trying to do the right things, and this is just bad. There's a question of where did it come from? So this is something I wanted to address too, because I think that this kind of gets to the problem of COVID overall in the US and everywhere else. So the variant was first identified in South Africa, where there's some heavy viral surveillance in the I can never pronounce, I don't speak Afrikaans, so I can't do the name Gauteng province, the most populous section or province of South Africa. There's this ongoing surveillance. And it came up with the sequencing, it was immediately flagged, and they noticed that they just had a huge number of these cases all with this same variant. Go ahead.
Can I ask you a question about that? I'm very fascinated by evolution generally, probably one of the main topics of the show, but I don't know much about virus evolution. And how do you identify what is considered a new variant, where it's like, like mammals, you have speciation once they can no longer breed or whatever. How does that work with a virus?
Yeah, even that's up for debate, because we definitely call Neanderthals a different species, right? But they've certainly interbred with humans, right? So yeah. So So this is sticky because I actually don't know the International Committee for Viral Taxonomy's standards terribly well. But for variants, I think there has... I actually don't know. The simplest thing for me to say is I don't know. It's the simplest thing.
Solid answer.
Yeah, but the ICVT has standards that they hold everyone to. So what's interesting about Omicron is that at the moment, keeping in mind that viral surveillance is not great, and there's large sections of the world where this isn't happening. At the moment, the closest variant that it can be related to was around in mid-2020. So there's this big 6-month gap. Not 6 months, sorry. Almost 18-month gap between the a confirmed strain that has been identified and this thing. So what we think is that there's no intermediates, at least not yet. And there could be that as more things are sequenced, these intermediates will be found. But the fact that there's that big of a gap and this thing is so successful suggests basically one of two things, which is that it's been, or one of several things, and they are all kind of the same, which is that it's coming from some unmonitored location or being, right? So when we've seen stuff like this in the past with other diseases, they've emerged from, say, immunocompromised populations. So MRSA, there's a certain type of MRSA that can literally just make a wound on its own. That emerged out of the New York State prison system. Legionnaire's disease, first time it's identified, it's a group of legionnaires.
Yeah, it was existing before that from was it cooling units?
Yeah,
bacteria in cooling units, and then it was it was that legionnaires had gotten together at a hotel, so they had contact tracing basically, right. which they didn't have before that, and
right, yeah. So
there's also what was the never mind. I don't remember what I was going to say.
So it could be from an animal reservoir. That's possible. But I would say where humans transmitted it to something else and then it reemerged back in humans later. So that's always a possibility. But the upshot is wherever it came from, it's probably an unmonitored location. It's an unmonitored being or location. And for it to have been identified in South Africa, I think has some interesting implications because Delta came out of a fairly poor city that was isolated in Brazil, where a lot of young people are in this location. A lot of people are very poor. Brazil has some of the worst rates of tuberculosis infection in the world. And
tuberculosis. There's a nasty kind of tuberculosis in Russian prisons. I believe
yes,
that
X-strains
started springing out a couple decades ago or something.
Yeah. So X strains of tuberculosis, completely, fully antibiotic resistant, and exceptionally. So a good run of TB, average run of TB is 12 years, longer potentially. Untreated, but these can take people out in a few years by comparison. So yeah. And again, Russian prison system's a really good example of maybe what's happening. So South Africa has a really, really high HIV rate, a large number of people that are untreated. This is the outcome of an awful lot of wealthy nation fuckery that happened in the 1980s and 1990s. Including fuckery from the Vatican. So I think that, when we're thinking about these strains and where they're coming from, they're the outcome ultimately of wealth hoarding by nations that have a great deal more money. So if you want to prevent things like this from happening, you need to treat problems that are on the ground that are leading to vast numbers of people being, highly immunocompromised. So if this were happening in an old age home in Canada, there'd be a whole bunch of legislative changes around the management of like old age homes. And then you would have like, standards for testing and, like make sure everybody's getting fed, and we're going to eliminate these other baseline diseases that immunocompromise people so that we don't have to worry about this threatening them and everybody else. That's not the way that we've treated HIV or any number of other diseases. So, yeah.
And so because I want to address a common thing that by the way, not listeners to this show, but this is good to give them information for the type of things that they're going to encounter when they're talking with their own family and such, is that this is just something that's happening or impacting immunocompromised people or people in poor health, but it's easier for a virus to attach to someone who's vulnerable, but then those vulnerable people can amplify a virus and spread. Like I hope I'm thinking about this in the right way. I was just reading about Hydra virus a little bit in Australia, that this rare horse virus that is probably coming from bats, and it can't go from bats to humans, but it can go from bats to horse and then amplified in the horse and then passed to humans.
Right. Yeah.
After that. And so in that same sense that it can then get amplified, is that along the lines of what you're saying?
Yeah,
people with HIV are more susceptible, but then can become amplifiers and spreaders of
I think that the way to think about it is that a cell is a hell of a resource. For a virus, a cell is everything. And so it's the difference between a healthy population would be like a petri dish with agar, and an immunocompromised population is a petri dish with like enriched agar, right? There's all these cells and you've got fewer in the way of defenses. And so a virus in an immunocompromised person can develop higher loads. There's just potentially more virus. They're more likely to be infected in the first place. And then there's just that much more virus replicating all the time. So, so that's a way of thinking about it. When you have a room of immunocompromised people, then you can have like expedited evolution either random by drift or by selection in one person, spreading to another, spreading to another, spreading to another. And so, immunocompromised people is where you would expect. And this was something that was identified, like it was mentioned in commentaries at the very beginning of the pandemic, that it's immunocompromised people that we're going to see these like major leaps and changes being made in. So in variants or one of the places. And so therefore they need to be prioritized for vaccination. Not just because like it's in their interests to like survive an infection, but because it's in everybody's interests that they, right?
There's global travel and
right, exactly.
Everything now.
And so it's funny because we took that attitude in wealthy nations for like our own citizens and residents. No one is effectively, like for decades ahead of time, has taken this approach or thought about it in the context of, say, like HIV in sub-Saharan Africa. Like we talk, I should say, like we haven't talked about it that way because the reason why we have X strains of tuberculosis stems directly from the HIV pandemic, right? It's that HIV and TB live in this, like, at least for TB, it's a very good relationship where if you are HIV positive, you're more likely to have tuberculosis. There appears to be a relationship between HIV infection and superinfection with TB, where like for reasons I can't remember, but it's been defined, TB can better access cells and better take up in the lungs and better form granulomas and get about its business. And so HIV and TB kind of go hand in hand now. And so it's via that we have these X strains because of misapplied antibiotics, because of, large numbers of people walking around with TB who are immunocompromised, lots of antibiotics. It doesn't make a difference necessarily. You end up with virulent strains and you end up with strains that can't be treated. So, anyway, so all that to say, like I guess I'm not my statement isn't totally correct because we talked about it with TB quite a bit, but I don't know that anybody thought about TB, the common person anyway, thought about TB from the same perspective. Like I know when I was a little kid, TB was just not around. Like you didn't hear about it. Nobody talked about it.
You see it in like an old West movie or something like that.
Yeah. You know, like, so if you were really into, who is it? Puccini, then yes, you talked about it, right? Because what's the opera where she dies of? It has Musetta's waltz in it.
I'm so uncultured.
La Boheme. There we go. Sorry. Yeah. So she dies of TB, right? And so like it's this 19th century disease. We have the advent of antibiotics, you know, blah, blah, blah. But with the emergence of HIV, it definitely becomes like a thing. And so, you know, we've talked about it as reemergence, but people in wealthy nations are largely spared. And so it's easy to ignore.
It doesn't. I think the U.S. has. I think we have a doctor per 400 people or something like that in the U.S. I think Africa has a doctor per 40,000 people, and so if someone might want to do their due diligence and fact check that, but I think that's pretty accurate.
That's pretty. Yeah. So did we talk about this last time that Uganda there was a calculation in 2012 of how many ICU beds does the entire nation of Uganda have that would be suitable for treating sepsis? And it was 40.
That is laughter's this odd cathartic thing that happens that shoots out of you even when things are horrifying.
Absolutely horrifying, right?
My God. That is crazy. That's in, and so these I mean it's
so that's
I started watching this. There's a Netflix show about pandemics that came out in like January of 2020. I like finding these books that came out just before COVID or docuseries or whatever, because it's like you'll see them talking about like, we're really worried about a respiratory virus coming from bats and things like that in this area in particular, in these wet markets and blah, blah, blah. This is like all this stuff, footage and shot like well before COVID happened then released before COVID.
What's that movie Black Christmas where you're like, no, don't go upstairs, get out of the house, right? I feel like if we were watching this now, it's like, get out of the house. Yeah.
And it's because, well, this is part of you hear even like Jon Stewart made some joke about the lab leak hypothesis stuff, and it's like there's a thing, it came out of Wuhan and there's a Wuhan lab there, which is we should probably talk about lab leak stuff, just because it seems to be another way in which people come up with another way to like deny, to be like someone else's fault. You do, like, even if it was like no one during Chernobyl was like, your guys' mess, I'm gonna stay right here. But it's an interesting, the correlation and causation thing. It'd be like if there's a polar bear research station and some odd thing happens to a polar bear and people being like, this research station must have been making these weird new polar bears or something like that. Like, no, that's just where you go to research polar bears. That's like, if you want to research insects, like consider moving to Arizona, or if you want to like research scorpions.
So this is not a perfect example, but Lagos in Nigeria has one of the world's foremost viral level 4 viral labs in the world. And it's there specifically because this is a region where HIV emerged. This is where Marburg and Ebola is from. It's there because it's the place to do this work. Wuhan's interests in lab's interests in coronavirus are totally legit for a whole bunch of reasons, including that a great many of the ones that have gone around the world appear to have come, not great many, but ones in at least SARS and clearly SARS-CoV-2, but SARS in particular came out of that region, came out of there, and possibly Southeast Asia as well. And plus, we know that the bats that are, so something like, I was reading a study from like 2017 that looked at Stewart et al. 2017. I can't remember where it was published, but it was looking at rodents, primates, and bats. So there are 7 human coronaviruses, right? All of them, as far as we know, come from bats or rodents with some intermediate host in between, usually, right? So it was primates, rodents, bats, 20,000 animals, nearly 300 species. Every bat they tested, it was something like 91% of all of the coronavirus or SARS-related coronaviruses that they found were found in bats, and 96% of all the bats they sampled were positive for SARS-related coronaviruses, right? Bats have a massive, huge swath of the earth that they cover. The ones that we connect to this current outbreak in particular, horseshoe bats, which seem to be close. They're carrying stuff that's pretty damn close to SARS-CoV-2, cover a length of space from like Southeast Asia down into like sub-Saharan Africa. It's enormous, the geographical region.
I think, aren't they maybe connected to Ebola too, the horseshoes? Or is that?
Well, so there's a lot of different types of horseshoe bats. Yeah. Yes. So I believe that that's the case.
It went horseshoe bat to chimp to human, I think. Is
it's also been passed through other intermediates, right? So like anybody who's going to eat a bat or is going to travel into cage. There's an outbreak that happened in I can't remember, it was early 2000s, that was probably dogs that went into a cave. There were hunting dogs that went into a cave and came out. So it moves very quickly. Yeah. There's definitely a case that was from a necroscopy of a chimp. So there's a bunch of different ones, but coming back,
there's something about that just makes me want to eat a bat so bad. It's like that forbidden fruit.
Yeah, right. It's like, they might feel a little bit like crispy wings, like extra crispy chicken wings. Yeah,
I joke, but it is. But there are. It's as an American, it's like. It's like, oh yeah, people in parts of the world eat bats. It's something that takes a moment to wrap your head around.
Yeah, that is the case. But I mean, there are a number of the transmissions for Ebola, for example, are thought to have come from animals that ate bats. So it was people eating the animals that ate the bats. Yeah, and that is true that bats are sold in wet markets. They are sometimes eaten. There's an awful lot of really cool science that happened right after SARS, looking for antibodies in people that were in regions where bats are known to be like frequent, and you would find SARS-related things. Well, antibodies circulating that identified SARS. So that could be a SARS-related coronavirus. It could be SARS itself. The thing is, coronaviruses really don't mutate that quickly. What's really interesting about them is that they've got a proof-checking mechanism, which is kind of rare. They have proofreading enzymes. Part of the reason for that is probably, it may not be fair for me to say this, but so their genome is really funny. It's a huge genome. It's absolutely enormous for a virus. It's like 30 kb. It's really, really big, lots of nucleotides. But when it's replicating in the cytoplasm of a cell, so one of the things that makes positive stranded RNA viruses threatening overall is that they shoot their genome into a cell and it's ready to go. Like, it's with very minor modifications, it's ready to be read, and it's read like its host RNA. And then it can just start making stuff. Whereas like other types of viruses can't do that. They have to go through other machinations before anything can happen. So that makes positive stranded RNA viruses sort of threatening. That's why people are always surveying and looking for them. But one of the things that's sort of interesting is that for coronaviruses anyway, it's a huge genome. they transcribe about 9 sections of RNA in the process of trying to make like themselves, like replicate themselves. And it's discontinuous. So when they're making their genome, when they're replicating their genome, they're not setting it up to be read all at once and made. It's like in a bunch of little sections. And so those little sections can get scrambled, and that's not good for function. So they've got these proofreading. One of the things that helps them is that they've got this proofreading mechanism. And as a result, they just don't mutate that fast.
Yeah. Yeah. So that's so interesting that something that seems so from the point of view of the gene to evolve something that corrects for mutations is such an incredible innovation to stumble on. But then at the same time, because it in our modern world, in terms of infecting humans, it's actually more beneficial for viruses to not have that thing,
right?
To mutate more.
So one of the things, so coronaviruses, because of that, so several things. Because they're kind of conservative, that works to our benefit. This is an exceptional virus, right? In that it's like global dissemination. But, most of the other ones that we knew about before SARS, the 2 that we knew about before SARS also had global dissemination. And after SARS, we discovered another 2 that caused common colds, and they had global dissemination. And this is something that coronaviruses do. They're really good at disseminating. But
what's that when you call them conservative? What does that mean? They're kind of thrifty in the amount in the amount of energy that they're consuming?
Oh, I don't know if that's the case, because they maintain this epic genome. Like, the flu is like half the size. It's huge. It's like, if I were going to sit down and look at like big genomes, it's for a virus, they're among the biggest genomes there are. So it's not thrifty from that perspective. I mean more like it's evolutionarily conserved. They're so all positive stranded RNA viruses mutate pretty quickly. But these guys, because they have this proofreading mechanism, they're more evolutionarily conserved, meaning they don't change that much from generation to generation.
I see.
The reason why we're seeing all of these variants is because of the sheer number of infections that are happening.
Yeah.
Oh my God. So there's some other cool things. All right. So, no, go ahead.
Could I just in terms of those variants, say you get back. So another cognitive bias I see springing up quite a bit is kind of this black and white thinking. This has happened all through COVID with any form of mitigation. There's like, some people have an expectation where if something isn't an absolute silver bullet that completely, if masks don't stop 100% of the spread all the time or whatever, that therefore let's just write it all off. If vaccines don't completely stop every case of COVID from happening or stop you from spreading 100%, then they don't do anything to limit infection or spread. And isn't it the case that vaccines do actually offer some protection from actually getting COVID because you're building up your immune response so that it's ready to act at the first sign of the virus. Right?
So so that's an important point, right? The only way they work is if you get infected. So, but they prevent you from, so insofar that there's a difference between the virus and COVID, right?
Yeah.
So that SARS-CoV-2 is not COVID, COVID's the disease, then yes, they certainly can. So people should be less likely to exhibit symptoms. They're certainly less likely to be hospitalized. They're less likely to potentially suffer any number of complications as well. So that's good. Yes. So but it's not perfect, and they never are perfect. And one of the things that's really amazing about this is that the efficacy is so high, but they're not perfect. They're a really good example of how most vaccines require additional protection. So like polio, that vaccine is effective for not just because it's effective on its own, but because we have water hygiene practices that keep it from moving around in, or at least keep a lot of it from moving around in water. So
interesting
to have it, right? So there's lots of things, and you need to take a Swiss cheese approach to this, right? Like if you layer all of your Swiss cheese on a sandwich so that all the holes line up, you're going to be disappointed. I actually hate Swiss cheese, so it's not really a great thing for me. But but you're going to be disappointed. You're just going to at some point you're going to bite, and it's just going to be ham. You're going to be like, that sucks. So yeah, you need to take layers of protection.
In terms of spread, I mean, I guess so theoretically considering that your immune system when trained and boosted with vaccines is able to respond to the virus in a more adaptive way, it is limiting the spread of the virus inside of you, right? So therefore, isn't it also lowering the amount of potential virus transmission? I guess the other side is if you don't have symptoms, you may walk around spreading.
There are lots of people that don't.
Without.
So that's something that's important. Lots of people are asymptomatic. In fact, at least 60% of people are asymptomatic. So, and all of those people can transmit, and it's getting better at transmissibility. So one of the things that appears to be important with Omicron in particular, but it's been the case with Delta, was the case with Delta as well, is that there are switches in amino acid sequence where these spike proteins bind to cell receptors. And we think that, so there's a recent study that came out that said that just one of these mutations is potentially responsible for an increase in binding affinity to its target receptor by over 1,000-fold compared to Delta. So that's just one amino acid change is potentially responsible for that. So that's what we're up against, I guess is what I'm saying. But that said, coronaviruses are really good at immune escape. And I think we talked about this before, but but I just sort of very broadly said they're excellent at immune escape. They really are. But one of the things that we've found is that Pfizer found, looking at people that had been vaccinated, was that early studies with Omicron show that there's escape from neutralizing antibodies. So these would be antibodies that were developed as a result of vaccination. They seem to be as bad as 8-fold less likely, or less able to neutralize Omicron coming in. So, and Delta was about 4-fold less. So that's some of the reasons why we're seeing breakthrough, is that the neutralizing antibodies themselves. Now that's important. There's a bunch of different reasons why antibody levels are measured and thought about when we think about vaccination and immunity. For one, it's an easy way to measure things. Honestly, they're big, they're easy to find. It's a lot easier to look at antibodies circulating than it is, say, to look at how T cells are responding specifically. Neutralizing antibodies are important because there's something that can take out an infecting microorganism on its face. They can do it on their own without assistance. But antibody levels overall are important because there's a number of other immune cells that can't do anything or are less effective if antibodies aren't tagging the target. And so when we see these differences in response between variants, it's important not just because it means killing the thing on the way in, but it also has implications for how the rest of the immune system is going to orchestrate and organize around this infection. That said, that's just antibodies, so that's effectively a small portion of B cell responses. There isn't a really clear notion of what's happening with T cell responses, and T cells are really important too for a targeted response, killer Ts in particular. So there's at least one study right now that suggests that Omicron is no better at escaping T cells than any other variant that's come up. So right now, these mutations appear to affect whether or not Omicron can escape this like first wave of neutralizing antibodies. That's one of the reasons why Pfizer said a third vaccination is important, because they found that with a third vaccination, people had higher levels of neutralizing antibodies and they were more likely to detect and take out Omicron.
Now, is it the case that we'll theoretically need to keep on getting boosters, or is it that because I know there's plenty of vaccines that work in stages too, like isn't that like a 3-dose thing first half of your life and then another 3 doses later on or something?
I don't know, because I couldn't get it until I was in my 40s and they just made me do it over 18 months, like Hep A and Hep B, which is also done over an 18-month period. But yes,
I'm kind of talking out of my ass.
No, that's totally fine. It's they stage it, I think, differently for like, you know, the young generation coming up that's not going to have to think about cervical cancer. I guess I'm probably naively optimistic in thinking that because this is an evolving situation that we're still learning more about it. Might it be the case that there will just be like a number of stages that we need to hit, or do you think that it's going to be continued boosters for so different pathogens and different epitopes so molecular signatures on those pathogens are identified by not always defined subsets of adaptive immune cells like B cells and T cells. So we don't always know what subtype is seeing them, and there's so many subtypes that we may not even know about. And each of these subtypes likely lives for different periods of time. So we've known with flu, for example, that flu vaccination may last 10 years. The problem is that the flu dies, right? It changes so quickly, right?
I see.
But there are people who we see a drop off in immunity after a couple of years. It occasionally happens with influenza. With COVIDs, this has been consistent. So like since SARS, when an awful lot of energy started going into how long do we see circulating antibodies that identify this, they're gone by year 3. And that we've known that for about 20 years. So I think that, I don't know exactly what kinds of antibodies, but with the tests that are used that are sort of broadly grabbing at antibodies, that's the case. So I think it's probably fair to say that we will be boosting indefinitely, at least for now. Yeah.
I mean, it's like no one wants to hear that, but I got my first one was, knocked me out for like a day after my second dose, and then I just felt like a hair off after my booster, and it was easy peasy where I was. I didn't even book an appointment. I got
walked
it.
in. Same thing.
I got it on day 181. Actually, they had to check the math on it because the date was like earlier than, so they had to count the number of days. But anyway, I could care less if I've got to go and get vaccinated every 6 months. It sounds a lot better than a hospital bed. And also I have, I shattered my foot years ago and had surgeries and stuff, and it was a whole ordeal. I almost lost my foot at one point, but it's given me an appreciation for, what can happen when you have a sustained chronic health issue. And it's like, it's given me an insight into what aging is like as well. Because I have one foot that's like 75 years old.
Yeah, no doubt. I have a back that's the same.
Yeah. But what about natural immunity? My editor might bleep or edit this out because maybe it's personal, but not to, I don't like going the route of anecdotes, but my goodness, people love anecdotes so much. But my editor's sister's in her early 20s and recently got COVID for her fourth time. She's unvaccinated and works at a makeup counter, putting makeup on people in Dallas, Texas. And I don't think she's I think she's just like young and didn't get around to getting vaccinated or whatever, but 4 times. And
4 times in a very face-to-face job in a place that has a ridiculous COVID.
Yeah.
Poor her.
Yeah. And, but the reason I ask is like that, I mean, that's just an anecdote, but that doesn't give me a lot of confidence in natural immunity. Is there any, none of hers were awfully severe. I think it like knocked her out some. I don't think she had any long COVID symptoms or anything, but is there any connection to, I don't know enough about immunology, obviously, but the severity of the disease, will your immune system kind of remember better theoretically if you got hit kind of harder, like your immune system's like, we better pay extra special attention to that one. Whereas if you have kind of a mild case, it doesn't do the same work to.
Right. Okay. So, I don't know if there's any information that would suggest that if you had, say, a mild case versus one where you were sort of laid out, but not in the hospital. So if you were asymptomatic versus if you're, had symptoms, that suggests that your memory response would be any better or any worse. Because honestly, we don't develop great memory responses to it on its own anyway. Mm-hmm. So there's that.
I see.
But if you'd asked this question 30 years ago, the response would have been something along the lines of adaptive immunity is everything. And things are remembered for different periods of time. Getting infected will confer some kind of immunity. What we know is that with increasing severity in infections, and just for certain types of infections, bone marrow gets reprogrammed. And the result after the fact is not beneficial. At least in the context in which it's been currently studied, it's not necessarily beneficial at all. And so one of the things about post-sepsis syndrome, for example, is that some of that is, a lot of it's attributed to simply having been in an ICU. So there are things that happen in an ICU that lead to like physical damage, like being on a ventilator does damage to lungs. If you're put on a ventilator, that is like pretty serious business. A ventilator is likely to kill you. So there's, it's pretty serious to be on one. Not likely, but it can kill you. Especially if you're young and small bodied like a child, you're more likely to take on damage. So, but there's other things as well in that if you have a severe infection, we know that bone marrow will reprogram so that responses are either potentiated later in life or they are blunted later in life. And so we know that there's alterations that lead to increased susceptibility to other infections after the fact. So I don't know if that's like a good way to think about it. And I don't know that there's any, I don't know if there's certainly, I haven't seen anything on immune programming. It's referred to as innate immune memory. I haven't seen anything on that.
And how is it, so I see that it seems that the vaccine protection seems better than natural immune protection, and if you've had COVID, you should still get vaccinated, and there's even more protection. And obviously, you don't want to go out getting yourself COVID for the additional protection because that eliminates the point. But how is that? How does that work? How does a vaccine produce a better immune memory than the actual virus?
So there's a couple of things around these vaccines that are proprietary, but if we're just thinking about, say, Moderna versus Pfizer, Moderna and Pfizer. Those vaccines are basically some salty water and then a proprietary lipid solution that's like polyethylene glycol that has different freezing temperatures, depending on the vaccine, wrapped around the mRNA. You throw it into somebody in muscle tissue, and that polyethylene glycol, that lipid layer, will bind to the cell and then shoot the RNA in, and the RNA gets read, and then you make as many copies as as deemed necessary by the cell, and for as many copies of the mRNA that gets in there, right? So one of the things might be the sheer load of what's going in. mRNA in and of itself is immunostimulatory, so there's a therapeutic index for it. Like there's a point where if you shot enough of that into somebody, you would definitely hurt them. But it's been all worked out for this magical amount where we know this much is effective and it falls below the threshold of hurting somebody. So, so some of it might just be the load. The other thing is that, so the live virus, that has an awful lot of mechanisms that are designed just for escape. So the first is that it's very small. It can get through mucous membranes very easily. The second is that once it's inside, one of the most important ones, I think, is that once it's inside, it makes use of all of these pathways in a cell that would ordinarily be used for other things. So it gets in by a process known as endocytosis, meaning it kind of gets swallowed and it sits in an endosome for a little bit. When it's in the endosome, it's manipulating receptors that are in there so that it can't be seen. It shoots its RNA out into the cytoplasm, and there's a whole bunch of mechanisms that are in play there so that it can't be seen too. And then, it has to put itself together. Every time a virus puts itself together, there's DNA and RNA that goes, there's RNA that's produced in this case that doesn't get used or gets chucked around. There's an excess around. And these viruses make enzymes that clean that up, that go around and get rid of any excess so that it's not detected. So with the vaccine, you don't have to worry about any of that. With the actual virus, you could take potentially even the same load and you might not get the same response because you've got this active mechanism, an active series of mechanisms honed over. Some of these things are 4 billion years old. Or some of these mechanisms I just discussed are shared all across positive stranded RNA viruses. And they've been manipulating host cells before they were eukaryotes. So, you don't really stand much of a chance against something like that. For a host to be able to take something like that out is pretty rare. So one of the reasons why the vaccine is more effective is just it's a target. You make a target. It's clean, simple. It's not escaping anything, and it's done in a couple of hours. Yeah.
And as I'm hoping that this has inspired some people to get their booster, because a lot of people, I know I have a lot of listeners that are vaccinated, and then, I know a lot of people that have gotten the booster and they just kind of got around to it when they didn't go on day 181 like I did. And people that take it seriously, but just haven't gotten around to it. But I get asked about mixing sometimes. And is it little bits of stuff that I saw, just, some people I follow on Twitter or whatever, seem to think that there was a little boost. The stuff that I've read, it kind of convinced me to think there was a little boost in mixing. I had got Pfizer the whole way, and then I was like, oh dang it, maybe I should have mixed I kind of want to collect them all, but
so here, like My Little Ponies, get them all. So okay, so all right, this is a byproduct of it's a partial byproduct of the U.S. hoarding the vaccine supply from the rest of the world, where other wealthy nations had to go and mix. Very, very early on, the UK had an interest in seeing if AstraZeneca would work with Pfizer, because those were the first two vaccines that seemed to be the closest to approval. And AstraZeneca is the Oxford vaccine, although honestly, you guys threw a couple of billion into its production, so it's as much an American vaccine as anything else. Anyway, so the U.S. hoarded all of this stuff, and all these other wealthy nations had to make do getting whatever they could get. And so the approach was For AstraZeneca, which is this traditional vaccine, they rear up proteins and they throw them in, and it's a couple of, it's tri or quadrivalent, I can't remember. It's got a couple of different proteins in it. So it's hitting off a lot of different targets. And for Johnson & Johnson, which is hitting off the whole of the, the whole of the pre-fusion mRNA sequence for spike protein. So the whole of spike protein is in there. Whereas Pfizer and Moderna are targeting slightly different sections with some overlap of a very conserved, tiny region of this spike protein. The approach was, what if we get this vaccine, these two vaccines, which are of lesser interest? The efficacy was good, very good, but lower than the other two. And they take longer to produce. That's the most important thing, is that they take a really long time to produce by comparison. So a lot of these nations snap those up and then set up a scenario where you're vaccinated with those. And then if we get Pfizer and Moderna in, you can be vaccinated with that. There have been trials running in the UK from very, very early on that showed that Pfizer and AstraZeneca worked well together. And in subsequent trials, Johnson & Johnson and Moderna appear to be an effective combination as well. But what happened in places like Canada, where they had to mix them, is that they found that when they were surveying people after the fact, they found that they had the antibody drop off just wasn't happening as quickly as it was if you just hit someone with just Moderna or just Pfizer. And so there does appear to be a benefit in mixing. For the time being, the FDA doesn't have an opinion on mixing.
Because that's what I've been telling people to do. The
FDA doesn't, as far as I know, have an opinion on whether or not Pfizer and Moderna are worth mixing, although there has been some commentary on that. So it's possible. I mean, I would assume a couple of different things. I think we're still in this very delicate period where the vast majority of the world is not vaccinated and has no access to vaccines. And so there's two ways to deal with that, right? The first is you can and should appeal to your politicians to ask for the patent rights to be repealed at the level of the WTO, of the World Trade Organization, so that nations can make their own. Mm-hmm. And there's plenty of, like Lagos, for example, has this fantastic, level 4 facility. They could, in Nigeria, potentially make this and distribute it to nations around, and this would be fantastic, right? But I think the other thing is that, so you don't want to hoard, but I think the other thing also is whether or not it's effective to collect them all. So I think in those two combinations, we know it's effective. In Moderna, Pfizer, you'd have to the way I would do it would be, get your booster for the one that you started with, and then potentially get another booster for the other one. But I don't know that that's necessary. They overlap in sequence pretty strongly.
And if there's the antibody decline, people are going to think I'm crazy for saying the people that are listening to this just furious with me right now for being a big pharma shill and this and that. I'm like Bill Gates is signing me checks every time I tweet about COVID or something. But to my tiny following, as like all the conspiracy peddlers are just having a field day right now and there's like people like Russell Brand and stuff, his videos that do conspiracy stuff just do so much better than others. And this like JP Sears guy is like, he sells like anti-vax, anti-Fauci like merch at his comedy shows. It's just like the dumbest stuff I've ever seen in my life, and has gained about nearly 1 million followers since taking this path. And then after his videos, sells a supplement to increase muscle mass, and he's clearly taking steroids, as you can see from his skin. But so there's a lot of bad actors out there. But anyway, but me talking to random people that I find, I'll get accused of being some corporate shill. But is there a downside to getting boosted more frequently? As you say, there's antibody decline, and I live in a country that has an abundance of vaccines.
I would say that we don't know. I would boost on the schedule that a number of jurisdictions are suggesting. They differ a little bit by jurisdiction based on availability, but I would boost on the schedule that's currently recommended, which is like right now it's 8 or 9 months after your full vaccination.
Yeah.
Right. So that's here in Canada, where you could wait months to get a booster. They're necessarily boosting at like a longer stretch, but the vaccination took a longer stretch too. So for us, the doses of Pfizer and Moderna were available at the trial's optimal times, right? Which was like 21 days and 28 days. In Canada, I can tell you that they were waiting 4 to 5 months between those two doses. And that's something else that might be contributing to this longer lasting. So it's going to differ by jurisdiction, just because the dynamics of vaccine rollout differed by jurisdiction. I don't know if it's necessarily safer to get them, or even safe to get them earlier, so I would go with whatever is being done where you are.
Are you excited about any treatments coming out? First off, we should talk about ivermectin, because a lot of people think that they can not get vaccinated and count on ivermectin when they need it, or you're even taking ivermectin ahead of time. And I got this was again, I had heard about ivermectin. So what happens is that like the stuff will happen on like web forums and stuff, and conspiracy people or whatever will get wind of it, or these wellness people will get wind of it. And then 9 months. So I'd heard about like ivermectin back in like fall of 2020. It was something like being explored. And because there was like medical sites where people were like, well, if this does end up being approved, I want to be sure and have some, and there might be a run on it. So like people that would nerd out about stuff would find these things out anyhow. Then 9 months after the fact, like this podcaster, scientist Brett Weinstein did this emergency announcement on Joe Rogan's podcast, and about ivermectin, and he's just a grifter that presents himself as like this freedom fighter. He got expelled from academia, and so you can't just go on. Again, you can't just like be an interesting person with interesting things to say. You have to have done something, like you're fighting the system in some way. You can't just like be some boring person dealing with the bureaucracy of the system or whatever. Right.
Can't just be a cog in the machine.
Right. And so since that time, then it's like everyone's, and then Aaron Rodgers, the Wisconsin quarterback, who gets his COVID advice from Joe Rogan.
Yeah, his quote was just killed me. I don't understand why the NFL will not consider my research. And I was like, the NFL won't think about my research either. But that's fine.
Oh my gosh. And so there's, my take on it is that there was doctors were throwing whatever they could at it early on, because it would be strange if a antiparasitic drug worked as an antiviral, right? But there was some fudged data early on with it, but it seemed like in some regions there was actually some improvement over controls, and what happened was it's in areas in like India that have high parasitic loads, so people were having worms. Treating, it'd be like if you were starving and you got COVID and someone fed you, you would do better than a starving person that didn't get fed and had COVID. But food isn't actually a cure for COVID. It's just better to treat other things.
Ivermectin, and specifically ivermectin for humans, because there's a difference between the vet drug and the human drug on its face. There's always a difference between vet drugs and human drugs. They're just indicated differently because the standards for approval are different. So they are different drugs. But the human ivermectin has been applied for years in very impoverished regions for deworming, right? Because having a high parasitic load is like indicated for all kinds of other infections, including viral infections. And so one of the approaches to like even like any number of viral infections, including like polio and tetanus and things like that, has been, tetanus? No. Oops. Okay. Well, polio, we'll go with that, has been to apply ivermectin. And measles and any number of other diseases has been to apply ivermectin because you improve someone's health overall in the process. And also the other thing is that in
a region that's like near the equator that has a lot parasites, that has sanitation issues,
so another thing that like helminthic worms in particular are very, very good at. They're very, very hard to get rid of on your own, and the reason is because they just exquisitely manipulate host immunity at a cell-by-cell level. They can express their own they're little animals. They can express their own cytokines. They can and pass them off as being human. They manipulate anti-inflammatory responses and pro-inflammatory responses so effectively that they change cell signaling. And so, so to have them means that like on a cell-by-cell level, you have this, your intrinsic cell defenses are down. And so, to get rid of them is a good thing, right? So all of that.
If you have worms, you should get rid of worms, whether COVID or anything else is around.
I mean, those who are super into the hygiene hypothesis would say maybe otherwise, but I think that there's a balance here. Having worms is not a good thing. Having worms, I mean, everybody has a certain number of worms, but like having worms that, are like asthma and allergies versus, having tapeworm that gets into a leg or something. I mean, this is what we're talking about, right? Like necrosis so there's plenty of reasons to not have worms. So ivermectin for that, and it improves the health overall, and therefore you're more likely to be able to like set up a reasonable antiviral defense. I'm very excited about the idea that Joe Rogan won't have worms, especially if he had been eating raw bull testicles. I think that this is like, I'm very excited about that. I'm not so excited about the draw on horse ivermectin in the vet med market or any number of other things that may be a downside of this. But it is a hoax. And so, don't use your aquarium cleaner. Don't inject bleach. Don't.
Oh my God. There's a new one where people are, I don't know how much this is happening, but because some people are bending to vaccine mandates to keep their job and getting vaccinated. Now there's a thing on TikTok where people are offering solutions to get the vaccine out of you. And
so possible.
They're like taking like odd toxins and baths and things and weird.
Not possible. So so just to be real clear about how this works, right? That lipid layer binds to cells almost immediately. We're talking about seconds before it's inside of a cell. And then the RNA is in there for maybe 2 hours. By 4 hours, it's gone. One of the great things about RNA is that it like disappears very quickly. So,
that's sorry, I'm a bit of an interrupter when I get very excited about this. And I'm always excited to talk to you, but one of the, that is a thing where people, I mean, I guess we've talked before and it has happened in the past where there are, like rare side effects from vaccines that don't express themselves necessarily immediately, but it is when people are like, well, you don't know what that vaccine is going to do to you like 10 years. It's like the vaccine's not in me. It's like it disintegrates like really relatively quickly, right? So is there
that's the case for all of them.
Yeah, so that's like
so on the topic of what it might do, we have there's a limited number of very, very rare side effects that come up with certain vaccines, right? So Guillain-Barre is probably the most famous of these, which is something that's potentially indicated for these vaccines, but it is something that happens with like influenzas where it was first
in like the
discovered.
70s or something like that.
Yeah, and
when
it
they did the big
causes
push.
Yeah.
And that was I think that was one of the first like anti-vax times too, right? Because it was like because there was a prediction that the flu is going to be much worse than it ended up being, and so some of the like rare side effects were because
there's a very, very serious flu that went around in 1968, right? The Hong Kong flu circulated and killed people, and it was like pretty bad. And so there was after that there was this big push for like for vaccination and things of that sort. So Guillain-Barré happens with flu infections anyway. And it's very, very rare for the vaccine to trigger it. But it's brought up, it's indicated because like if you've had Guillain-Barré, there's the thought is that like you are likely to experience it again. And it causes paralysis. It's, it's a serious condition to have. That said, exceedingly rare. And in terms of things like autoimmunity, I can't bring any to mind that are known to trigger autoimmunity. So then stepping away from that even further with the polio vaccine, polio is a live attenuated vaccine. You shed it, similar to the rotavirus vaccine, which is not on the US schedule, but it's on the schedule of a lot of other nations. You shed it. And so in the case of like the polio vaccine, there's a certain number of escape mutants every year that end up in waterways. And so as a result, there are people who get polio because other people are getting the polio vaccine. But
interesting.
It's like a couple of hundred people, like worldwide. It's not very high. And then let's see, I'm just like trying to run through the rest of them here. There's, so one of the things that happened with HPV, the HPV vaccine, if you haven't had it, hurts. Like I hate to say it because I don't want to discourage people from getting it. The notion that cervical cancer will be a thing of the past is like so overwhelmingly awesome that I encourage anybody to get it who can. But man, it burns. It really burns. And as a result, there are people who develop what's called a vagal response. So this is common for like anytime somebody sticks you with a needle, no matter what they're doing it for, people will have this like vagal response where they like faint or they, they may have other weird little neurological disruptions, but it's about anxiety. It's not.
Yeah. Like a kind of a nocebo effect or something.
Exactly. So in terms of what this thing can do, we know that the responses die off after 3 years, and we know that the RNA is gone after 2 hours. So you don't really have much to lose.
Yeah, right. I hear the shingles vaccine is a brutal one.
Oh, really?
Yeah, I had a biologist friend who Barrett Klein, he's been on the show a bunch, and he got it recent, but he had gotten shingles as well at some point, and that was way terrible. Worse. Yeah, he described it to me, and it sounded really bad. But he got vaccinated, and he said it was much worse than the immune response to getting the COVID vaccine and stuff, which I mean, it's not insignificant for people to, not like that they have to feel off for 2 days or whatever, especially we're kind of, we're not the best at, I'm not the best at long-term thinking, and I haven't made every perfect decision in life. And so I get it. And it's also like, I was having a discussion with some people are like, some people can't afford to take 2 days off of work or whatever, which, I mean, you can always schedule on the weekend. And two, I was just like, well, those people that can afford to take 2 days off of work because of a vaccine certainly can't afford to take 3 weeks minimum off because of COVID, can't afford a $80,000 hospital bill.
But this is a thing where like there needs to be regulation around like people being permitted to go. Right? There are employers that are like there are employers who have very clearly an interest in guiding what these guidances will be, right? I mean, so there needs to be something like that allows, or you're going to have to start like bringing people to vaccinate your staff into work. Yeah, I agree. Oh, well, so then there are people who are allergic to eggs. This is a concern. So a lot of, especially viral vaccines, traditional vaccines are raised in chicken embryos. And so, yeah. And albumin, human serum albumin, and egg whites are basically all albumin, is used often as a stabilizing reagent in vaccines. So people who are allergic to eggs and certain types of adhesives can't get vaccinated, so there's things like that. And of course, there's like certain immune conditions where you can't get vaccinated as well, which is why it's all the more important that if you can, you should. Right. Go ahead.
I know that I don't want to keep you here all night because I always,
this is our longest one.
This is the longest one. Do you want to break?
2 hours.
I mean, I love talking about this stuff, so I'm happy to have, but you need to go at some point. Oh shoot. Did you need to go already? Should I let you go? Or do you have a couple more minutes?
Soon because I'm sharing the wall with a very young child who's going to go to bed soon. But yeah,
I'm sorry.
No, it's totally fine.
Let's wrap up. So one, going back to, I brought up ivermectin because legitimately I wanted people to know if there are treatments that you are excited about. I heard like the Pfizer pill and some other things, and also so I have I got this Fitbit around this time last year that I told you that I in a Stanford study that like alerts me to immune changes or whatever. So theoretically I would possibly know if I have COVID before I have symptoms and get tested and everything. Is there, I know that treatment can change at various stages in most illnesses. If someone has a COVID test and they test positive, what do you recommend doing?
Oh, go isolate. But in terms of how you treat yourself?
In terms of, is there anything available yet that you can get get a jump on it and get something from your doctor or anything that's close to being delivered?
So if you test positive, and I believe in most cases you would need a PCR test for this. If you test positive and you have, say, high blood pressure or you have diabetes, there's a number of different conditions that, depending on your state, qualify you to get, I believe it's depending on your state, qualify you to get monoclonal antibodies or antibodies, convalescent sera. And you can have reactions to that, depending. Some people have reactions, but generally speaking, that's the first, most readily available thing that can be applied. The Pfizer pill, the FDA was talking about some of this today, and I meant to look into it, and I didn't get a chance. I'm not sure if it's even on the market. They had some release on it today, so there's some sort of hang up there. And in terms of everything else, super strongly recommend. The best thing you can do is to take it easy, right? It is to rest and wait it out. And if your symptoms get worse, you need to go to get supportive care in the hospital. What I would say about stuff that I'm excited about in the future. So there's some trials right now to repurpose HIV drugs for the purposes of trying to limit replication, that this might be something that could be effective. And I don't know if you know how this works, but heart therapy, which has been applied to HIV since 1997, is the reason why whole generations of people think of HIV as this sort of chronic disease that nobody has, at least in the US. Takes a crack at, it's a 2-hit system where it takes a crack at viral release and also aspects of viral replication. And so there's some stuff there that I think could be really, really, really interesting to hopefully would work out. But the best thing right now is that. And then if you're in the first couple of days, remdesivir is another option that can be applied. And for people who have risk factors, that's the that's the approach right now, as far as I know, is remdesivir monoclonal antibodies. And that's what you can do. That's better than what most people can do if they were to come in with a severe infection of unknown cause, which is what most sepsis cases are. There's one thing I wanted to talk about that we were talking about, and now I've forgotten all of the things associated with it. So I just brought it up and literally forgot as I was talking. But there's something that we were talking about, and I completely forgot what it was. Damn it. And I didn't get to say what it was that I thought was important to say. Oh, well.
Maybe it'll come to you. I wanted to quick ask, what about this current peak with the holidays and everything and these very high numbers? Do you expect a dip again around February or so this time around, or does the Omicron just completely change the game?
I don't like to put the emphasis on viral mutations so much, because at the end of the day, it transmits because people are in a position to be transmitted to, or to transmit to somebody else, right? So I think that if we were following all the rules that we're supposed to be following, we wouldn't be seeing flu cases going up. And so Omicron is very, very transmissible, and it is a threat, and we shouldn't take that lightly. But at the end of the day, it's human behavior that's driving a lot of this. So what I think, so I've been thinking about this a lot. I think that our decline is going to look different this time around. So the holidays, we're going to see, I mean, clearly this is how it's working in the US now, right? Which is, we're going to see this ramp up over the holidays, and then we may see a die off. Last year, it started to die off into February, and then it got very, very low around, April, May. And part of that, though, was that there was this uptake of vaccines. So that by like May, something like 50% of the US population had been vaccinated. That's not going to be the case this time. So that beneficial hit is not going to happen. And so I think we may be looking at elevated levels. We'll see a decline, but it'll be elevated. And so, yeah, I don't know if we'll have a sweet May, June, let's all have happy barbecues. I'm hoping that's the case, but I think that the decline's just not going to be as great. And it's going to keep rolling like this. So I wish it was nicer. I wish I could say nicer things about it. One thing I will say,
you've been correct every time so far. So
I mean, I'd like to be wrong. I would love it if suddenly it dropped off and it looked exactly like it did last year or better. But
I mean, what if I mean, it also seems like the vaccine rates, if there was some change where the vaccine rates went up, because I don't know, but the measles vaccine, every time that drops below like 91% or something like that, measles starts popping up a couple decades later because of the susceptibility. And so, I mean, it seems like without a huge percentage of people getting vaccinated, like, we're really in for it. No matter, even the vaccinated people. And
I mean, so I would remind you that like kids 4 to 0 still aren't vaccinated. So we still have that hump to get over, right? And I think things might improve. They will improve when that age group is vaccinated. That's being delayed because the trials so far have not been great. But once that group is vaccinated. Well, so Pfizer found that the dose was probably not effective. So they have to run the trial again. So we're looking at another 2 months, which is, whatever, it's coming. I mean, I don't know. But I think that like I said before, there are no before times, and we're going to have to come up with ways to like work around this. And so, and there needs to be more protections for people so that we can. Yeah. Gosh, I wish I could remember the other thing that I wanted to say, because it was like super awesome.
It was good news.
It was good news, I thought. Yeah, but I just can't for the life of me remember.
you were excited about something coming up, like we were talking about treatment stuff, and
yeah, it had something excited to do with that. Yeah, for sure. But I don't remember. So one thing I will say that's depressing that we can get close to ending on is that the notions that Omicron is mild is a little weird. So the current stats are like kids appear to be about 20-fold more or 20% more likely to be hospitalized with Omicron. And there's some suggestion that it might spend more time up in the bronchus than it does in the lung, but and that might have something to do with its structures for little kids are really small. But yeah, so so we're talking about, when people talk about a pandemic of the unvaccinated, it includes all these kids that aren't even eligible. And so just to, when you're going out, to think about those sorts of things, right? Like,
what if you're going out to a place that requires vaccines to be shown, and so 100% of the people in, say, a venue at a show are vaccinated? Like, does that make you feel safe? I mean, no,
it doesn't make me feel safe, but my circumstances are a little bit different, right? So I guess, like, insofar that a bunch of very healthy people who are vaccinated are in a room together, all 100% of those people are vaccinated, and 100% of those people can pass this virus back and forth and can pass it then to people on the outside. That's a bummer. If they're all vaccinated and they're all masked and they're distanced, as opposed to being crowded all in together, then that's even better. If somebody somewhere sometime would make some infrastructure changes around ventilation, that would be awesome. I mean, I think that this is the level that we're at now, is that we have to think about, like, filtration systems. Like, it's not enough to just keep forcing people into a position where, like, to make a livelihood, we have to cram people into a room and say, well, you're vaccinated, this is good enough. So, I mean, there needs to be these other changes. Not to make you feel bad. I mean, I think that this is fine.
No, it's fine. It's just like planning out my life as a,
it's just like,
as a stand-up comedian. I'm like, I think I'm not a stand-up comedian anymore.
But I think like, if you want to do that, I think it's fine. I think the responsibility is higher than this. It's at the state level, right?
Yeah,
so it's not okay to say, like, okay, restaurants can reopen. Let's put everybody in plastic tents out on the sidewalk. It's okay to say, okay, restaurants can reopen, and here's the money to, like, get a HEPA filter. You know, here's how we're going to structure things from now on. So yeah, and I think, you know, with comedy clubs and stuff, I know that, like, people being together matters, but
I mean, the thing is that it's like, it's not just about safety as well. If I didn't care about people's safety at all, there would still be a consumer confidence issue. And I often do science shows too. And so the people that are science enthusiasts are going to be less interested in packing shoulder to shoulder with strangers indoors, even if I want to make money doing that.
Well, I think that, so there's other things that, I mean, so it'd be great if there was, like, all these changes to buildings that allowed for better ventilation and, you know, and heat at the same time, and et cetera. But, you know, with improvements with rapid testing, that's another thing that could make it, like, that could make a big difference. If people are able to test themselves frequently.
Why aren't they delivering masks, N95 masks and tests to every single person's door immediately? Like, it doesn't seem that expensive.
Yeah, not to throw her under the bus, but Jen Psaki said the quiet part out loud a couple of weeks ago, right? Which is that we don't want to pay for 150 million tests for every single home.
But you're going to pay for it one way or another. You're going to pay for it in your healthcare system. I mean, it's like, it's like not wanting to pay for an oil change. Like, but do you want to pay for your engine to explode?
Right. Yeah. I mean, at some point we want to keep the transmission, right? Right. Yeah. So, I mean, like, I think that there's going to be these technological improvements that'll help with things, but there's no way that we get out of this, or at least to some semblance of normalcy that's workable, without major adjustments being funded by government agencies, and without, you know, a doing away with the notion of individualism. And if we can't, you know, we need to get there we need the CDC, for example, to write respectable, reasonable guidances.
Well, you've been a terrific guest. If you think of the thing, one, you can just pop back on for a couple minutes to remind me sometime, or just email me and I'll include it in a outro.
And by the
or
way, she
something
wanted
like
to say
that.
blank.
Yeah. It's up to you, but it doesn't matter. But this is a fantastic conversation, chock full of all sorts of wonderful information, and I would certainly rather hear the truth of things, even when it's not always pleasant, than to live my life in denial of them and pay the consequences of that later. So thank you.
Oh, hey, no problem. I'm happy to be here anytime you want me here. Let's check back in the spring.
Sounds good. Yeah,
right?
let's do
That'd
that.
Be fun.
Yeah. Let's do it.
Very
Springtime.
cool.
All right, Jessica Brinkworth, everybody, and thank you, listeners, for being such wonderful, curious people. Stay safe out there. Get boosted. Hope you're all well.